History matching method in reservoir modeling. Firstly, it's our content, introduction, objectives, main part, conclusions, and the references. Firstly, what is a history matching? History matching is the process of creating reservoir geological model to match the model from fields production data. This tool is a very handy tool for efficient reservoir management by using past and present data. Because in oil gas industry, return of assets are very significant. It helps to create future optimal reservoir production with high performance. History matching aids to update present reservoir model and optimize future production prediction. In this picture we see, firstly, we must create geological model. Model constrained to static data, structural, seismic, logs and the cores, and so go on. And after that, we run this geological model with dynamic to create dynamic data, fluid flow model. And after this process, we get history matched data, and so go on. Its process is returning. There are types of methods for the history matching using different algorithms like genetic algorithms, Markov chain, Monte Carlo, Kalman filter algorithms, stochastic, probabilistic, 4D time-lapse methods. History matching is the process of determining the values of the set of reservoirs properties such that a simulation model best reproduces observed data from various disciplines. The model can then be used with increased confidence in forecasting. Main objectives. Reservoir engineers, by given data and creating geological model, will improve previous prediction by updating current model. For history matching is not just to match historical data, but to enable the prediction of the future performance of the reservoir and thus production optimization with regards to economy and the oil and the gas recovery by improved or enhanced methods. By creating more realistic model as possible, history matching provides list of benefits. Model calibration, which helps to improve and validate reservoir description, prediction of future performance with high degree of confidence, enhancing the understanding of the reservoir, detecting operational issues during the process of reservoir management. Objectives of saturation match individual well water cut behavior and the individual well gas oil ratios behavior. It is a breakthrough times, water cut performance, log derived saturations. To get good quality match, also used additional tools such as analytical coning models, single well simulation models, Buckley-Leverett analysis, Stiles analysis, Dijkstra-Parsons analysis, stream tube analysis, cross-sectional simulation models, and so go on. History can be matched by using a single model of integrated model, and it is represent different scenarios how reservoir performance would change. For example, in this picture we see with the red line it's the historical data, and with the green it's our two scenarios. It's also would be uncertainty. How would change our production data, how will we change our water cut. It's the main goal to estimate how we'll change and how we'll predict the future data. There is 4D modeling, 4D seismic data which monitors fluid flow from the wells. A model that has an acceptable match to production data may no longer be retained if the match to 4D seismic data is poor. To help find better models, automatic inversion methods may be also used. There is the Fedkovich type curve analysis. This is a special equation which we can find optimal and the predicted rate. In this graph we see how the pressure at the bottom hole changes from 2500 almost to the zero, and there is types of tubing sizes, and for each tubing size we have the optimal rate. History matching process involves making numerous simulation runs of the reservoir with a minor adjustment to input parameters until a satisfactory match is achieved. This makes history matching time-consuming and costly. In practice, a final match is often declared when the time or money allotted for the study is depleted. Quality of history matching. There is no any standard which describes quality of history matching. A clear understanding of the study objectives should be used while defining what constitutes a successful history match. For example, pressure may be considered matched if the difference between calculated and observed pressure is within the tolerance 10% drawdown. The tolerance of 10% is determined by estimating the uncertainty associated with measured field pressures and the required quality of study. A study demanding greater reliability in predictions, as we said before, may need to reduce the tolerance to less, like 5% or even less tolerance. In conclusion, history matching now very important process during the field production. By this process can predict changes in reservoir parameters, so it is handy for manage reservoir competently, time and resources to increase efficiency or recovery factor. By the year accumulated experience gives results in using history matching processes. In combination with the additional tools, history matching will be more accurate. So there are a lot of types of analysis and the methods which are using in the world. In unique situations, all of them could write in some degree, but not for 100%. Engineers and scientists working to improve and upgrade current methods to get more enhanced history matching. So it's our references which we used. Thank you for your attention. Goodbye.